Hi guys, this is Achyut. So we are going to solve the today's LeetCode question, which is largest divisible subset. So we are given an array, and we need to find the largest subset answer such that every pair of elements in the subset satisfies the condition. One of these two conditions should be satisfied. So let me give an example so that we can understand better. So this is the given array. Suppose let's take only 1, 2 till 4. This is the given array, and we need to find largest subset such that all the elements which are picked from this array should be divisible. Yeah. Let's consider like then we can pick A1 and A2 and A1, and then A3 and then A2, and then A3 and A1. So these are the different possibilities which we can pick from this array to different elements. Suppose if particular case any one of these conditions should be satisfied. That means A2 should be divisible by or A1 should be divisible by A2. For this particular case, A3 should be divisible by A2 should be divisible by A3. For this particular case, A3 should be divisible by A1. A1 should be divisible by A3. So these are the two conditions which should satisfy so that it will form a largest subset such that it satisfies one of these conditions. So how can we remove these two conditions into one condition so that we can check easily? Suppose let's think A1 is less than or equal to A2 and is less than or equal to A3. Why? Because we can sort the array and then from that we can say always largest number is divisible by smallest number. So we can say that, right? Because the largest number cannot divide the smallest number. So by using that logic, we can sort the array. From that array, we can get the whatever required subset we can get, and then for that particular case, we can divide and then check whether it is possible or not. So for these three possibilities, what should be the conclusion? Suppose let's say A2 should be A2 and A1 is picked, then A2 should be divisible by A1. Why? Because A2 is greater, so A1 should divide A2. So A2 divides A2 is divisible by A1. And then for this particular case, as we are saying A3 is greater than A2, A3 should be divisible by A2. And what about this one? A3 should be divisible by A1, right? This should be done. But if we see this carefully, suppose let's think A3 divided A2 divided A3, and then if we say A1 divides A2, then we can say A3 will be divisible by A1, right? Why? Because let's consider here 1 comma 2 comma 4. So suppose if this is true, that is 2 is divisible by 1, and then 4 is divisible by 2, then we can say that 4 is will be divisible by 1 as well. So we can remove this condition when these two conditions are satisfied. So we can check this. We can check this like for this particular condition, the next element should be divisible by previous element. And this particular case, the next element should be divisible by previous element. So for any case, we need to consider the current and then previous element. If the previous element divides the current element, then we can say we can form the subset, and then it will be largest based upon the length. So that is the logic. So one more thing we are going to store is dp of index. This will store the length of subset we had picked. We had picked length of largest subset we had picked, and ends at index. So what we are saying is it will be the largest subset we had picked, and then it ends at this particular index. Suppose let's say we got dp here, dp of a1, and then dp of a2. This will be index. Let's say I2, and then this is I1, and then this is I3, dp of I3. So these indexes will store the length of the subset we had picked, and then it should end at this particular index. So whenever we want the answer for this particular case, we are going to consider previous elements are as all the previous elements. So this can be I2 and this can be I1. So out of these two cases, whichever we find like it is divisible by previous elements. Suppose A2 is divisible, A2 will divide A3, then we can say that we can form the subset. And we also need to take care that that particular case should be largest subset. That is dp of I3 should be less than whatever element length we are getting. So that is the logic for this particular case. So we are going to code the same thing, and then as they are saying, like we need to return the largest subset answer. So here we should not return the length, we should return the largest answer. So we need to take one more array, which is parent of index. Suppose let's say this is parent of I3. Suppose this is the largest length we can form. Then parent of I3 will be I2. Why? Because the previous element is this one. And then for this, if this is the case, then we can store I1. So let's code this up so that we can understand. So let's take TP of index as it is saying like 10 power 3. So we can solve it via n square time complexity. So this is TP, and then we are going to take one more, which is parent of 1001, and then we are going to mark every index to -1, and then parent to -1, and then we need one more thing is vector of answer, which will store the largest subset answer. And then one more thing we need is maximum index. So let's assign this to 1 -1 as of now. And then one more maximum length. This will store maximum length we can get from the subset array. So let's take it as -1 as of now. And then we'll go through each and every element in the, before that we need to sort the nums. Why? Because as we had mentioned, If we did not sort, then we need to check all other condition like two of this condition. If it is sorted, then we can directly calculate and then do it. So we are going to sort this. So I'm sorting here. So this is parent and DP initialization, and this is the answer. And then we'll go through all the elements which is present in the nums, and then we are going to take all the previous elements which are previous to this particular index. And then for the previous one, we need to check this condition. Like the current, whatever the current A3 should be divisible by A2. So we are going to check that. If nums of I is divisible by nums of j. And one more thing is we need to take care of dp, the length of this particular case. Suppose let's say there is only one element. Then we are going to say that only one element is formed and then that length is 1. So here we are going to say dp of I is less than dp of j plus 1. Then we are going to assign the dp value, which is dp of I equal to dp of j plus 1. And then we need to store the parent of I, which is j. Like the previous element will be j because this is the largest, so we need to store that. And again after this, we need to store the maximum index and then maximum length. So that let's say the maximum length is formed here at I3. So we need to know this index so that you will get here. And the previous like the parent element will be this one, so we'll get here. And then previous element will be this one, so we'll get here. And then at last we'll see the minus one. So when we get to minus one, then we'll stop. So if maximum answer is less than dp of I, then we are going to say maximum answer is dp of I and maximum index is going to be I. So let's take this as maximum answer. And then after this, we are going to call maximum index not equal to minus 1. Till this time, we are going to insert into the subset, which is nums of maximum index. And then we are going to say maximum index move to the parent. And then we are going to return the answer. So let's check whether we have any errors. So we are taking the DP to store the length. We are taking the parents so that we can store the previous element. And then for this, we are assigning to minus 1. And then we are taking vector answer so that we'll store this answer. And then we are taking maximum index so that we'll know where the maximum length is present, the end of the maximum length. And then this will store the maximum answer length. And then we are going to sort the given array. And then we are going through each element in the array. And then we are saying the maximum, like the minimum it can be with the length of 1. Why? Because we can take one subset like which it will be, it doesn't need to satisfy any of the, because there is only one element. There are no two different elements. So for this particular case, the previous elements can be, it starts from 0 to I minus 1. Till I minus 1, we can pick any previous element, and the current element is divisible by previous element, and the answer which we get from that particular, which is the length which we got that ends at j plus 1, is less than what we had already calculated. Then we can say dp of I is equal to dp of j plus 1. And then we are going to say parent of I will be j. And at last we are going to compare with global maximum answer, which is dp of answer is maximum answer is less than dp of I. Then we can say maximum answer is dp of I, and maximum index will be I. And then while we are traversing in maximum index, we are going to push all the elements which are present here. Like suppose if it is A3, we are going to push, and then we come to A2, and then we come to A1. This is the answer. Let's see. Let's run this. Yeah, let's submit. Yeah, it's passed. Yeah, thanks for watching the video. Do share, do like if you like the video. Thanks.